So in section 3, we're going to talk about ways you can select random samples. More specifically, if you are doing an SRS or a stratified method, or even cluster. So for mainly those 3, how you can select those random samples. And then we'll just briefly introduce experiments as well. So when it comes to selecting random samples, there are 3 common ways. So the first one is pulling names or numbers or whatever out of a hat. So what you would do is write down all of the names for your population, or if you've already assigned numbers to everyone, the numbers on their own slip of paper, put all the piece of paper into a hat and pull out whatever N number you want for your sample. You do want to mention whether or not you're doing this with or without replacement. And remember, for our purposes, majority of the time, we're going to be doing these without replacement. Because when it comes to selecting a sample in these aspects, you don't want that sample to be able to be chosen more than once. The next one is in your calculator. So in your calculator, if you go to Math and then over to PRB, on some calculators, it's PROB. So that stands for probability, and then you would go to number 5, and that stands for random integer. So what you do is you give it your range of values. So the lower is the smallest number. Your upper would be your largest number. And then N is your sample size. And then what it does is it goes ahead and it will give you out a list of numbers. And then you'll just figure out, all right, who does this number correspond to? And then that's how your sample will be chosen. The calculator or computer generated numbers are usually the least time consuming to do because the calculator has a program and it does it for you. And then lastly, there's a table of random digits. So this is something that was already created. It's in a lot of statistics books. You can find it online. It is literally just a table of random digits. So it gives you strings of numbers between 0 and 9. So the digits 0 to 9. And they are grouped in 5s, mainly just to make it easier to read. But that group of 5 doesn't really have any meaning. It just breaks it up for us so our eyes can read it just a little bit nicer. So when it comes to using that table of random digits, what you would do is you first would have to label every individual in your population with a number. And depending on how large your population is, that determines how you assign your labels. And then from the table, you would start at your very first number, identify how many digits you're going to be taking at a time and separate them. And then you would ignore any numbers that are not in your range and anything that is repeated. Because again, we are doing this without replacement. And then lastly, once you know what numbers you're using, you go back and figure out who they correspond to, and that's your sample. Okay. So let's look at an example. So we have that the school newspaper plans an article on family-friendly places to stay over spring break at a nearby beach town. The editors intend to call 4 randomly chosen hotels to ask about their amenities for families with children. They have an alphabetized list of all 28 hotels in the town. Starting at line 140, find an SRS of 4 hotels, describe how you would select your SRS, and then collect your sample. So we have all 28 hotels. So when you're trying to figure out how you're going to number your digits, it's based on how large your population here. So my population is 28, which is a 2-digit number. So all of the numbers I assign to my list have to be 2 digits. So I have to do 0, 1, 0, 2, all the way up until 9 because I have to have 2 digits. And when it says starting at line 140, so there's hundreds of lines in this random number table. So you can just pick any line to start at. So this is what row 140 looks like in our table of random digits. So they're numbers grouped by 5. So because I'm looking at 2-digit numbers, every 2 digits I'm basically going to split. And I'm going to go between the groups. So like 5 is then going to join with the 1. So I'm going to create my 2-digit numbers for this line. Okay. So my first 2-digit number is 12. 12 is within my range of 1 to 28. So if we're talking about how you're selecting, so each hotel is given a 2-digit number between 0, 1, and 28. Okay. Then choose 2 digits at a time if it is in the range that hotel will be part of the sample. Skip any numbers that are repeated or not in the range. So anytime I ask you to describe how you would select your SRS, this is basically what I'm looking for. You tell me how you're assigning digits, how many digits you're going to choose at a time, and then basically talk about how numbers that are repeated or not in the range are going to be skipped. And then you'll go ahead and do it. So we look at our first digit. Our first digit is 12. Our first 2 digits are 12, which is within my range. So Hotel 12, which is the Holiday Inn, is part of my sample. The next one is 97, way outside my range, so I'm going to skip it. Then I have 51, also not in my range. 32, also going to be skipped. Then 58, also skipping it. Then we get 13, which is inside my range, which is going to be Lime Tree. Then we have 04, also in my range, which is Banyan Tree. Then we have 84, 51, 44, 72, 32, and then 18, which is also in my range, which is Sandpiper. And I have now reached my sample size of 4, so I'm done. And these 4 hotels make up the sample for my survey. So that's basically how you use a table of random digits to collect a sample for an SRS. Next, we're going to do a brief introduction to experiments. So we're going to briefly talk about the difference between an observational study and experiment again, and then we're going to talk about some key terms that you're going to see in an observational study and an experiment. So first, just to review, an observational study observes individuals and measures variables of interest but does not attempt to influence the response. So the same definition we did in section 1, just putting it again here. An experiment then deliberately imposes some treatment on individuals to measure their responses. So just retaking those definitions from section 1 and putting them here again. So let's talk about 3 things that you're going to see a lot when doing either an observational study or an experiment. The first one is the term experimental units. So this one is specific to experiments because if you're not doing an experiment, you don't have experimental units. So an experimental unit is the things on which the experiment is done. So experimental units do not have to be people. They could be animals. They could be inanimate objects, especially if you're looking to do an experiment on like a computer or food or crops or something like that. Subjects is specific to when the experimental units are human beings. You can still technically call them experimental units, but they like to use the word subjects if you're doing human beings. So if I specifically say experimental units, not necessarily a human being, but if I use subjects, definitely a human being for an experiment. And then lastly is treatment. So treatment is a specific experimental condition applied to the units. So treatment is whatever you're deciding to like do to them, basically. Briefly mentioned how like in anytime you're doing like drug testing, a treatment is usually like a new drug or something like that. That would be a treatment. So let's talk about identifying something as an observational study or an experiment and being able to explain why something is an observational study or experiment. So we have that a medical team examines the records of 5 large hospitals and compares the survival times of those cancer patients who had surgery versus those who had chemotherapy. So when you're looking for things to help you identify, what you're doing here is we are examining records. So think back to when we were talking about observational studies. We said you could do something retrospectively or prospectively. This is an example of a retrospective observational study because you're looking at records. You're looking at something that already exists. So it's an observational study. Because you are looking at past collected data. Right. You're not specifically telling certain patients to have surgery and other patients to have chemotherapy. That would make this an experiment because you're imposing some type of treatment on those patients, whether it's, so they didn't have a choice in which one they were doing. Here they had a choice, so it's not going to be an experiment. Next, we have in gym class, the effect of exercise on blood pressure is studied by requiring that half of the students walk a mile each day while the other students run a mile each day. So here, the key term here is requiring. So that leads me to an experiment, because you are telling students to either walk or run a mile. Okay. If I wanted it to be an observational study, I would have the students choose, and then you would look at the differences. Next, we have that the relationship between the weights of bears and their lengths is studied by measuring bears that have been anesthetized. So anesthetized just means they've been put to sleep, because you can't really ask bears to sit on a scale and take their length while they're awake. So key thing here is you're measuring. There's not really a way to look at the relationship between weights of bears and lengths in an experiment. So this is an observational study. Because you are recording data about bears. You're not making them do something to increase their weight or increase their length to see if that has an effect on that. You're literally just saying, all right, I'm going to weigh this bear. I'm going to measure it. I'm going to look at to see if those two things have a relationship. Okay. Last one, people who smoke are asked to halve the number of cigarettes consumed each day so that any effect on pulse rate can be measured. So here you are asked to halve. So you are specifically telling them to do something. So this is an experiment. So subjects are told to cut down on cigarette usage. Now we'll talk about more, like for the two that were experiments here, we'll talk about more in section 4, whether or not these were poorly or well-designed experiments. I can tell you for sure right now, number 4 is a very, very poorly designed experiment. Just because if you want to see any effect on pulse rate, you should probably see what their pulse rate was before you ask them to start having their number of cigarettes each day, because you do need that base number to kind of see if there was really any change, not just, having them each day. Because if you don't know where they started at, it's really hard to make any decision. All right, now we're going to talk about determining in an observational study or an experiment which one you have, and then identifying the explanatory and response variables for each. So even if it is an experiment, there is still an explanatory and response variable. Observational studies have them as well, which we've already kind of discussed. So just kind of review. Response variable measures an outcome. Explanatory variable attempts to explain the observed outcome. So your explanatory variable is your x-axis or your independent variable. Your response is that y-axis or your dependent variable. So for our first example, we have that one effect of alcohol is a drop in body temperature. To study this effect, researchers give several amounts of alcohol to mice and then measured the change in each mouse's body temperature. So this is going to be an experiment because they are giving the mice alcohol. So can't really observe this really. There's no really observational study, especially if you're doing mice. And it's very hard to do an experiment with alcohol in this case because when you're doing it on humans, there can be detrimental side effects to alcohol consumption. So better done with animals. So here, my explanatory variable is going to be the amount of alcohol, because they're trying to figure out if the how alcohol drops your body temperature. So the amount of alcohol you consume would then tell you your body temperature. So my response is body temperature, because they gave the mice alcohol to then see how their body temperature changed. So one thing is, your explanatory variable is almost always going to be your treatment. It's what you do to them to see what the outcome is in an experiment. Okay. Next, we have that study is done to try and find the correlation between verbal and math SAT score. The scientist wants to use the verbal score to predict the math score. So this is an example, an observational study. Because we're just looking to see a correlation between the two. Now, in this case, they did specify which one they want to use to predict the other one. If they hadn't made that second sentence, there really isn't one that we would say is automatically the explanatory variable and one that is automatically the response. But here they specify they want to see if verbal score can be used to predict the math score. So my explanatory variable is going to be the verbal score, and my response is going to be the math score. Here we have that some breast cancer patients were given a new treatment. The patients were closely followed to see how long they lived following surgery. Weirdly enough, this is an experiment. It is a very, very bad experiment because you gave some breast cancer patients a new treatment. So you were giving them something, and very, very poorly designed, potentially unethical here. Because then they were just to see how long they lived following that surgery. So they weren't necessarily looking to see if it cured breast cancer. They were just saying, hey, how much longer are you going to live for this? So the explanatory variable here is whatever my treatment was. It doesn't specify what the treatment is, but considering that's the thing that I gave them, that's my explanatory. The response variable is then their length of life after that surgery. It also doesn't specify whether we're looking at days, months, weeks, years. Like, we haven't really specified length of life here, which is another problem with it, is that we weren't saying, oh, let's see how many years they live afterwards or how many days, which would make it even more unethical. And then last one, to find out how well a child's height predicts their age, a study was done where they measured the heights of a group of children at age 6, waited until they were 16, and then measured their heights again. So this is an observational study. It was conducted over a long period of time, which is very common in observational studies. Similar to this, is that you're going to look at data over a long time to see how it changed. So in this case, because we're actually looking at one thing, which is height, our explanatory variable is going to be, because we are seeing well how well their height predicts their age. So my explanatory variable here is my height. My response is going to be age. Which is not how we would typically look at something. We would say, oh, your age predicts your height, but they were very specific here to saying that they wanted to know how well a child's height predicted their age. So they're looking at it backwards, which is kind of different than what we would typically look at something like this for. Last thing just to briefly talk about is the number one advantage of an experiment over an observational study. And I kind of talked about this in section 1, is that with a well-designed controlled experiment, we can actually say that one variable causes a change in another variable. So that's the huge advantage to an experiment over an observational study, is you can actually say something causes something else. You can never infer causation with an observational study. No matter how well you design that observational study, you will never be able to infer causation. So that's why, if possible, experiments are used if you really want to say something causes the other. But if you just want to be able to talk about whether or not a relationship exists, an observational study is just as well. Let me know if you have any questions about using collecting data for an SRS, or being able to look at the differences between an observational study and experiment and identifying its explanatory and response variable.